Hey everybody, this is Larry, this is me going with Q3 of the weekly contest 306. Construct smallest number from DI string. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem. Yeah, so this one is, if you did the bonus question with me, it's very lucky and fortunate. I mean, I don't think it helped me that much for this problem, but it's still like, let me understand some aspect of it. So I'm sure it helped a little bit. But if you watch me doing a bonus question, I actually did one earlier today. We'll put in the comments or something. That was not this one, but a harder version of like, okay, given a pattern, how many answers can it possibly have? And yeah, I don't know. And this is just basically thinking about it along those lines. But again, the tricky thing is that, well, one is that you have to return the smallest, not just any. And I think there is a clever way to do this for sure. But the not clever way is keeping in mind that the pattern can only have eight things, and that means that the final number can have at most 9 digits, and that means that you can do this in 9 factorial times. And because each one will require looking at every number, you have 9 factorial times 9, which is about 3.2 million, right? So, and of course you can also say that this is just O of n factorial times n. And why I said that before I even look at the code is because now then, if I know that my upper bound is 9 factorial times 9, and it's only 3.2 million, then why not just brute force everything? That's basically the way that I did it. You could do brute force in a couple of ways. In Python, I was a little bit scared. That's why I was a little bit slow. Because, I was thinking about doing it recursively, but there is a lot of ways you can get it wrong recursive, or not wrong, but suboptimally recursively. And if you do it a little bit wrong, like if you didn't do it optimally in implementation, you can, instead of 9 factorial, you could do something like 9 to the 9 or something like that, right? Or maybe 9 factorial times like n squared instead, right? And that would be way too slow. So I was a little bit careful, and I slowed down just to make sure. But in constructing this is how you get this answer. It's just basically, well, brute force every permutation, and then see if it fits, right? And this permutation thing ensures that we basically go from the smallest permutation up. So as soon as you see a case where we, this is basically, if it's wrong, then we break and we go to the next one, ... If none of these is wrong, then we, in an else, we return the answer. And that's pretty much the idea here. So that's part 1, right? Or not part 1, but that's all of this problem. And you can get it, and I got it in 5 minutes, but probably a little bit slower. Got it in 1 minute, Jesus. But the natural upsolving question that you might have will be, well, can we do better, right? And the short answer is yes, you can do better. And this is kind of relating to digital DP, but maybe more digital combinatorics. And the idea there is just figuring out if a suffix is possible. Basically, you brute force on the prefix, and then you see if the suffix is possible. And then based on that, I think you're able to do it that way. And that way will be much faster, 1 digit at a time. However, and part of that, you can kind of look at the way that I did the other problem. And what I mean by the other problem is that my bonus question, you can use that solution to see if you can find a number that's within it. That's basically the idea. Yeah, let me know what you think. It's not easy for sure. but it is doable, and that's basically how you would do it. Is that you go, okay, if I put a 1 here, is there a solution? If I put a 2 here, is there a solution? If I put a 3 here, is there a solution? Dot 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 all the way on. And that's basically the idea, really. And then you say, okay, if 3 is here and there's a solution, then that's, recursively. Now let's look at the other number. Of course, that one is doable, but it is a little bit tricky. I imagine, like, I saw a couple of like really, really smart, like 3,000, like rating 3,000 people who took a long time on Q3. And I imagine, to be honest, that they did it that way. Just because that problem is also a known type problem archetype, so that's why. Yeah. Anyway, I get distracted because I think there's a fire alarm next door. You know that I record these explanations live. So I don't know. I hope that you didn't hear all the beeping because it's very distracting to me. But maybe my mic didn't pick it up. So anyway, all that said, hope I gave you stuff to play with and to observe as well. Yeah, brute force. Anyway, hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem. You could watch me solve it live during the contest now. Okay. No whammy. Huh. We just did a bonus question like this. But this is tricky, different. Okay, so it has at most 8 characters. So that's 8 factorial, right? 8 factorial is 40,000, so we can try that. Or 9 factorial? 9 factorial is 362,000, so we could just do that. Yeah, okay. 9 factorial times 9. That's cutting it close, but should still be okay. I think. If this times out, that'll be very sad. Actually. Yeah, okay. Let's just do it. No, because then now I'm doing a 9 to the 8. If I'm not careful. Let's see. How to do permutations in Python. Because in C++ I would just do permutation things, but nope. And then permutations of I guess just range n plus 1 really. Is that good? This is pending put pretty long. Let me think about running code while doing it. The server's a little slow. Okay, so that looks what I want. I promise you don't get any. How much time does that take? Without the printing, say. Maybe that's fast enough. We'll see. I might. This may time out. Okay, fine. greater than 2 sub I plus 1. Yeah. If padding of I is equal to decrease, then we're bad. If I guess here we can do else. Oh no, this is good. Oops. Yep. Work. Else we return T. I know that this isn't quite. Do we always have an answer? Okay. Oh, I have to add 1, I think. But that seems like the right answer. Whether that's fast enough is another story, but let's give it a submit. Okay, cool. People already gotten this, so it's... Hey everybody, thanks for watching. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem, my explanation and all this stuff. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.